Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning, everyone. Today I want to talk about ecosystem resilience and tipping points, and how those concepts should shape conservation and restoration strategies. When ecologists use the word resilience, they are referring to the capacity of an ecosystem to absorb disturbance and still maintain its essential functions and structure. That definition emphasizes both resistance to change and the ability to reorganize after perturbation. We also need to think about feedback loops. A feedback loop is a process where an effect feeds back to influence its own cause. Positive feedback can amplify change. For example, when coral cover declines due to warming and acidification, algae can take over. The presence of algae reduces coral recovery, and that makes further algal dominance more likely. When I mentioned feedback loops, I wanted you to understand how small changes can amplify and push an ecosystem toward a tipping point. A tipping point is the threshold at which an ecosystem undergoes a rapid regime shift to a different state. These shifts are often difficult to reverse because the new state can be stabilized by new feedbacks and by the loss of key species or processes. To make this concrete, I will give 3 brief case studies. First, mangrove restoration in coastal Bangladesh. Restoring mangroves has multiple benefits. The trees reduce wave energy and protect villages from storm surge. They also provide nursery habitat for fish, which supports local fisheries. In that example, restoration improves both hazard protection and livelihoods. Second, coral bleaching in the Great Barrier Reef. Repeated heat stress events have reduced coral cover and changed reef community composition. Once coral is reduced below a certain level, macroalgae can dominate and the system shifts to a less productive state. That illustrates how crossing a tipping point can reduce ecosystem services like biodiversity and tourism revenue. Third, the reintroduction of beavers in parts of North America and Europe. Beavers are a keystone species in many streams. Their dams slow water flow, create ponds, raise water tables, and increase habitat heterogeneity. These changes can increase regional biodiversity and improve resilience to drought. These cases show that conservation is not only about protecting species, but about managing processes, protecting keystone species, restoring physical structures like mangroves or beaver dams, and reducing external stressors such as pollution and overfishing all contribute to resilience. It is important to distinguish resistance from resilience in management goals. Resistance focuses on preventing change. Resilience focuses on enabling recovery and maintaining function. In some systems, preventing change is unrealistic, so managers aim to enhance resilience by restoring key processes. Another practical point is monitoring for early warning signals. Slowing recovery after small disturbances, increased variance in important indicators, or changes in species interactions can indicate proximity to a tipping point. Adaptive management that responds to these signals can prevent irreversible shifts. Finally, I want to stress that restoring an ecosystem after it has crossed a tipping point is often much more difficult and costly than protecting it beforehand. Restoration may require active interventions such as removing an invasive species, replanting foundation species, or engineering physical habitat. And even then, success is not guaranteed. In summary, ecological resilience, feedback loops, and tipping points are central concepts for modern conservation. Effective strategies combine protection, restoration of processes and species, and monitoring to detect early warnings. That is the framework I encourage you to use when evaluating conservation projects.
Listen again to part of the lecture. Then, answer the question.
When I mentioned feedback loops, I wanted you to understand how small changes can amplify and push an ecosystem toward a tipping point.
For more TOEFL mock tests, as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.